Hello and welcome to day 5. This is area of sectors of a circle. And so the first thing we're going to start with are some definitions of sectors and things like that. And so we need to make sure that we get these pictures down, so please pause this and copy it down if you need to. The first one is a sector of a circle, and basically it is the region between two radii and an arc of the circle. So basically we're looking at this piece of pizza here, and so when we're talking about a sector, we want to find the area of this piece, and that's what we're going to be doing. So there are ways to go about it, and if you think about it, if this is area, you could think about how we do area of a circle and what we were doing for arc length. It's kind of the same idea, except for we're going to use area of a circle. In the next one, we have a segment of a circle, and so we have a chord that is cutting the circle into two pieces, and then we're trying to find the area between the chord and the arc. And so what we would do, and we'll talk about this in the next one, is we would have to draw some radii to the end of the chord, and then we'll deal with the area of the sector. And then the last one is an annulus, and the annulus is basically two concentric circles, one circle inside the other with the same center, and we're trying to find the area of the annulus. Would be like the area of the shaded region out here, and so it's going to be the area as if the whole circle would be filled in, and then subtract away the area of the inner circle. So make sure that you get these drawings down, because we're going to use them on the next page. And so then to finish out our notes, here are some formulas that go along with it. Now remember, this is kind of like what we were talking about the other day, is that when we were doing arc length, that we were taking the angle measure and dividing it by 360, so the part of the circle that we want, and then we multiplied it by the full circle, because we only want the full circle would be the whole thing if the whole thing was shaded, but then we multiply it by the fraction that we want, and that will give us the area of the sector. And so that's what we're talking about when we're doing this. So that's where a over 360 came from, the degrees divided by 360 of the angle or of the arc, and then pi r squared is the area of the circle, so we're multiplying by the area of the circle times the fraction of the circle that we want. So that should hopefully make some sense. Then the next one, when we're doing the area of the segment, well, we would, like I said, we're going to draw the two radii, and the first thing we would do is we're going to do the same thing as we started over here. We're going to find the area as if this whole piece of pie was shaded in. And so we'd find the area of that piece of pie, and that's the a over 360 times pi r squared. So that would be our fraction of the circle that the piece of pie is taking up times the area of the circle. And then we got to subtract away that triangle, because we don't want that triangular part. And so then that's just base times height divided by 2. And then that will give us the area of the segment. So it's a couple step process, but that's what we're doing to find area of a segment. And then finally, the area of an annulus is basically, we would find the area of the big circle, like the whole thing from the center out, and that would be the whole thing shaded in, and then we'll find the area of the part that we don't want, the little circle, and subtract that area. And so it's just pi r squared minus pi r squared will give us the area of the shaded region that we're looking for. So this concludes the notes for this section. If you would come to class prepared for these, and we're going to talk about this stuff when we come to class.